Alright, well this is my third time trying to record this video. First two times I just wasn't recorded, so here we go. Third time's the charm, so I'm told. Tuesday afternoon, here we go. Geometric sequences, piece of cake. The difference between geometric sequences, what we learned Monday and Tuesday, is we're going to be multiplying. That's it. Instead of adding, we're going to be multiplying. So here we go. Geometric, not sure why I'm highlighting it green, but I feel like that's nice. So here we go. What a geometric sequence is a sequence whose terms change by, like I said, multiplying same number each time. When you do that, when you multiply that same number, you get something called a ratio. And in this case, we're going to have a common ratio, and we're going to use the letter R to describe that. It's super easy to find R because you take any of the two values and divide them. Okay. A couple of things to think of is the common ratio can be a fraction, like 1/4. It can be negative, like -3. And it can be just a positive number, like 10. So just stuff to look forward to. So here we go. First thing is we're going to figure out how to find a geometric sequence to determine if something is a geometric sequence and the common ratio. So you can think about how numbers are related to each other. How's 2 related to 4, 4 related to 8, 8 related to 16. If you said times 2, you're correct. And because we're multiplying times 2 every time, we get a common ratio of 2, making it geometric. The way to prove this is, well, you're going to take 4 divided by 2, and you get 2. You're going to take the next set of numbers, 8 divided by 4, and still get 2. And then finally, you're going to take the last set of numbers, 16 divided by 8, and you get 2. So common ratio is 2. Cool. Let's go to the next problem. Again, we're trying geometric, meaning multiplying. Obviously, you can see it's plus 10. But what we're going to do is we're going to do 30 divided by 20, and you get 1.5. From there, we're going to do 40 divided by 30, and you get 4 over 3, which is 1.3. And therefore, they do not have a common ratio. So no common ratio, and therefore it is not geometric. Okay. Right on. This last set, if I'm moving too fast, slow the video down. I don't know why I said that. Anyway, so you're going to take negative 25 divided by 100, and you get negative 1/4. Then you're going to take 12.5 and divide it by negative 25. And again, you get, you got negative 2. Oh, good. They're the same thing. And then the final one, we're going to do negative 3.125 divided by 12.5. And you're going to get that same number, negative 0.25. So yes, it is geometric. Cool. Let's keep going. This is how you write the recursive formula for a geometric sequence. N is going to represent any number, and R is going to be your common ratio. But very similar. Pause this if you want to write it down or make sure you have it. Cool. So here's how we find the recursive formula for the sequence. How are we going from 7 to 21, 63, 189? What you're going to do, let's identify this as A1, because that's our initial value, A2, A3, A4. Well, if I'm going to find the common ratio, I'm going to take A2 and divide it by A1. So A2 is 21, divided by 7 is 3. So the common ratio is 3. We know the first term is A1. So to write the recursive formula, we say we're going to identify A1 as 7, and then therefore we say A to the n, or A(n) equals A times n minus 1 times 7. Times 3. And that is the recursive formula. Pretty straightforward. We can use this to say, hey, what if I want to find the fifth number in that sequence? Well, you can say, oh, it's really easy. Just multiply times 3, which is right. But let's, if we know that, so let's think about this. So 189 times 3, we know our answer should be 567. Let's go ahead and use this, though, to help prove that. So I know a to the first is 7. But I want to find the fifth number. So we're going to do A. And remember, n's being replaced by 5. I'm replacing n with 5, so it's going to be 5 minus 1 times 3. So A4 times 3. Well, what was the fourth term? This means I need the fourth term of the sequence. So the fourth term of the sequence was right up here at 189, and therefore, no, that should be 5. Therefore, the fifth term of the sequence is equal to the fourth term times 3. So we know it's equal to 189 times 3, which we just did. So the fifth term is equal to 567. Okay. So anytime you see that, that's the fourth term. You know, A2 is the second term, and A3 is the third term. All right. Cool. Again, you might be given a problem like this. We need to identify two things. We need to divide the initial value. And so when you think of initial, hopefully you think of your initials. And your initials are what? The first few letters, or I'm sorry, not the first few, but the first letters of your name. So the initial value means the beginning. It's the start. So I have the first value, A1, is 18. The common ratio equals 1/2. So go back a slide or back to... back to the problem we just did, and what is it? How can I put this together? Well, we know the initial value is A1. We're going to define it. We define this at 18. And so we would say AN equals A, the n minus 1 times 1/2. Ta-da. Sweet. How nice is that? Awesome. Last slide coming up. A manager at a clothing store created sequences to show the original price and marked down prices of jeans. Write a recursive formula for the price of jeans. How much will it cost? Let's do 5 markdowns. Okay. So we need two things. We need a common ratio, and we're going to identify, the initial value A1, A2, A3, A4. Okay. So to find... really, it doesn't matter. We could say it's A4 divided by A3. It doesn't matter as long as the previous number is in the denominator. So to find the common ratio, we'll do 36.85 divided by 43.35. And when you do that, it should be 0.85. And it doesn't matter. I could do 51 divided by 60. And I still get 0.85. So the common ratio is 0.85. Now to write the recursive formula, we would say the initial value is at 60. And therefore, AN equals A times n minus 1 times 0.85. Now think about if we multiply by a number times 0.85, are we increasing, decreasing? Obviously, we're decreasing. So I'm going to just ask you this. What percent are we taking off every time we apply the formula? What percent of the number we're taking off? You said 15%. You were right. Just like Geico. Anyway, so if I want to find the fifth term, though, so we know the fifth term equals A. Remember, I'm replacing n with 5. So it's going to be 5 minus 1 times 0.85. So the fifth term, let me use a different color. Oh my goodness. Equals A. 5 minus 1 is 4 times 0.85. Well, what is the fourth term in the sequence? Because A fourth is the fourth term. Well, if you look up right there, we got it. So the fifth term in the sequence is the fourth term times 0.85. So after 5 markdowns, the $60 pair of jeans is now worth, or we want to sell it for. We're dealing with money, so it's 31.3225, and that rounds to $31.32. Anyway, don't forget to rate, like, and